Hello everyone. I will start my second video on psychrometry. We'll see some important psychrometric relations which are very easy and simple, and sometimes they are asking in the exam to write the expressions based on relations. So first one we'll see Dalton's law of partial pressure. Very simple it is. It states that total pressure of mixture of gases is equal to sum of partial pressure exerted by the individual gases. Just suppose if I have some PA, PB, PC in a some single vessel, whatever pressure exerted by each one is equal to the total pressure. Whatever he is seeing is that only. If each of the M occupies separately, the total volume of mixture at the mixture temperature. If we have some three gases, example is given here, A, B, C, at a temperature T with a partial pressure equal to PA, PB, PC respectively, then total pressure P is equal to what? Sum of all the three pressures PA, PB and PC. So if this law is applied to the mixture of dry air and water vapor, suppose I have in one container air which contains mixture of dry air and water vapor, means it is called as wet air. So wet air, if I see the pressure exerted on the container by air plus pressure exerted by that water vapor PV is equal to the total pressure PB. It is known as PB. We are denoting this as known as bulk pressure. So this total pressure is equal to PA plus PV. How we are writing this? Based on Dalton's law of partial pressure. Already he has expressed that what he has expressed, total pressure of a mixture of gases is equal to sum of partial pressures exerted by the individual gases. So here individual gases are A, B, C, but here in this expression, for which expression we are seeing here, PB is equal to PA plus PV. Means if I have already explained in a container, if I have air and one air, so that air contains dry air and water vapor. So dry air also exerts some pressure on the container and vapor also exerts some pressure on the container. So both pressures are equal, both pressures sum is equal to total pressure. So this can be applied using the Dalton's law of partial pressure. Next one, that further expression we are using in the further derivations. Some specific humidity, or it is also called as humidity ratio. We have seen already definition in the first video. What is that? Mass of water vapor present in unit mass of dry air, means per kg of dry air how much water vapor is present. Now we will find out some suitable expression to conduct to have one expression based on pressures. So let PA, VA, TA, MA, RA pressures of characteristics of a dry air. Assuming water vapor and dry air behaves as a perfect gas. What we have to assume here, PV is equal to MRT is applied for both dry air and water vapor. So for dry air I will write this equation, PA, VA is equal to MA, RA, TA. Similarly for water vapor we are using V as a suffix here. PV, VV is equal to MV, RV and TV. So according to Dalton's law of partial pressure, what is equal? VA is equal to VV, because volumes are equal, and temperature TA is equal to TV, because at that temperature and that pressure only the Dalton's law of pressure holds good. Right, now we'll take the this one, just divide by both numerator and this LHS and RH will divide. PV, VV is equal to these things, we'll do it, and here since VA is equal to VV, we'll cancel this, and remaining is PA by PV is equal to, here also temperatures are same as it is said here. Why I am writing this? When this holds good for both, these must be equal at constant volume and constant temperature, right? So only these are equal, so we will cancel. So I'll just mathematically modify this equation, taking MV by MA I want expression this side and relating other terms this side. So this MV, if it goes this side, MA it goes this side, PV will come up, PV into RA and PA into RV. So this expression is clear, I think so. Next, but Ra is equal to value we have for air, it is 0.287 kilojoules per kg Kelvin. Rv for vapor, till now we have not seen in the examples, but now it is here like this, 0.416 for vapor. Keep it in mind, this value is also very important in solving the examples. So Ra is equal to 0.287 and Rv is equal to 0.416. We substitute in that previous expression, we'll get mv by mva is equal to 0.622 pv by pa. But mv by mva is what? W. So this W means specific humidity. Specific humidity is 0.266 pv by pa. But pb is equal to what we have seen? Pa plus pv. Now I will take pa. Pa is atmospheric pressure or dry air pressure. Dry air pressure, Pa is equal to Pb minus Pv. So Pa is here, Pb minus Pv, this expression is substituted here. So this is the final expression for specific humidity. Now we will see for degree of saturation. So degree of saturation already we have defined in the first video only. What is that? Specific humidity of actual specific humidity to the specific humidity of saturated air. Actual specific humidity is what? W by Ws. But W expression we have seen this expression where in the last slide only we have seen just now, 0.622 PV by PB minus PV. Similarly, I can write this expression for this Ws also. What is that Ws? Specific humidity of saturated air. So wherever there is PV, just substitute with PS. Rest all things are same. So here 0.622, 0.622 PV, instead of PV we have to substitute PS because pressure of saturated air. Here pressure of vapor. So PB will be remaining same because of Dalton's law of partial pressure. Here what PV is equal to what we have taken? PA plus PV. Here PB is equal to PA plus PS we will take. Only thing is that is the difference. So now both expressions are ready here. Substitute in this equation. So if we substitute, 0.622 will get cancelled. So we will be remaining with PV by PS into this expression. So this PB minus PS, PB minus PV. So next we will see. Next, one more is relative humidity. We will see relative humidity. What we have written? Ratio of actual mass of water vapor given in a moist air to the mass of water vapor in the same volume of saturated air at a same temperature. Mathematically it is written as mv by ms. We have seen in the previous video. That can be written like this also, no? mv by Vv divided by ms by Vs, because it turns to the mass by volume is density. So density of vapor to the density of saturated air. That is also relative humidity. Now we have PV is equal to MRT for vapor and PV is equal to MRT for saturated condition, saturated air. So but what is this one? PV, Vv is equal, volumes are same, temperatures are same, and Rv here it is vapor and here it is saturated vapor, saturated air. For these two it is same, 0.461 value, but for Ra it is 0.287. Rv and Rs both are same, right? Now we have expression PV by PS is equal to MV by MS. So that is phi is equal to, remaining terms we need to substitute here. So PV by PS is equal to PV by PS is equal to MV by MS. This is the final term we are getting here, because rest all terms will get cancelled. Next, so this is one how if someone asks you to calculate PV, that is partial pressure of a water vapor. Partial pressure of a water vapor, it is been experimented and given one final expression. right? So this expression you need to remember. So Pw is what? Partial pressure at wet bulb temperature minus Pb minus Pw. Td means what? dBt. Tw Wbt. 1544 minus 1.44 Wbt. So that is Tw Td. So this expression we are using in the numericals. So this all given data are here. Pb is equal to barometric pressure, dry bulb temperature, and wet bulb temperature. So suppose he asks you to calculate vapor density. So that also we can solve using this formula, W into Pb minus Pv divided by Ra into Td. Td is nothing but absolute dry bulb temperature. Td is dry bulb temperature. So these two formulas are important. One more is there. Enthalpy of moist air 1.022 into dBT, that is dry bulb temperature. Specific humidity HFG at dew point temperature. So at this temperature only you should take out the HFG from the steam tables, and 2.31 dew point temperature, that is TDP. So this also last three formulas you need to remember for the calculation of numericals. That time again I am going to remind you. And till now what all we have seen in the first video definitions of important terms and definition of psychrometry. Second term, psychrometric relations we have seen. In that what all we have seen: expression for specific humidity, saturated degree of saturation we have seen, relative humidity, vapor density, enthalpy of moisture, and so many things we have studied. So all these things you need to revise again and note down the points. Next, thank you. We'll see the further points in the next video. So things are very easy. Just watch the video and study well. Thank you.